Hey guys, my name is Frank and this is the Python programming video log. Today you're going to watch me write a scrolling tile-based world example. So basically what you see here on the screen is what I'm going to be writing in pure JavaScript and HTML5 from scratch. So stay tuned to find out how it's done. Remember, if you learned something while you're watching this video, go ahead and give it a like and be sure to subscribe so you get my other videos. So I already have quite a bit of the code written, but basically just the shell. So I have the HTML, and that's going to set up all my HTML tags. It's going to set up my canvas element right here, which is inside the body tag. I have some CSS to style everything. So in the CSS, I'm forcing my canvas to be 100% width and height of the screen, and I'm making it fixed position. So that means when I look at my canvas element here, it's going to fill up the entire screen. It is not going to make it a pixel perfect resolution, however, and it's going to stretch the contents of the canvas. So we'll worry about that in a minute. Down here in the script tag, I've taken the liberty of already creating the tile map because it's really big and I didn't think you guys wanted to see me write all of those values in because that would probably get pretty boring. And down here is the end of the file so far. It's only 61 lines with lots of white space, so hopefully you guys don't mind me just skipping over most of this stuff and getting right to the JavaScript. So let's get right to the JavaScript. The first thing I'm going to do is I'm going to get a handle on the canvas so we can draw something. Let's go ahead and say var context equals document.query selector canvas. That's going to get a handle on our canvas tag, which is right here. Then we're going to go ahead and say .get context 2D. All right, so that's going to be our canvas. Now I'm going to go ahead and create the game loop. So I'm going to say function loop. It's just going to create a function. And I'm going to use window.request animation frame, the loop function, and that's going to perpetuate that function. Then I'm going to start the loop by calling loop at the bottom. And inside of here, I'm actually going to continuously resize the canvas. This way we have a good resolution on the canvas and the image isn't skewed. So what I'm going to do is I'm going to define var height. I'm going to set that equal to document element client height, and var width equals document element client width. And I'm going to copy these, and inside of this game loop I'm going to set those again and again just in case our screen size changes. This way we constantly have the correct values for the inner dimensions of our browser window on every frame of animation. Then what I'm going to do is I'm going to go ahead, I'm going to say context.canvas.height equals height, context.canvas.width equals width. So context.canvas.height and context.canvas.width are going to be height and width of the actual inner size of the browser window. Now I'm going to go ahead and just fill it with white just to see if it's working. So I'm going to go ahead and say, let's see here, context.fill style equals, actually let's make it a nice peaceful green there. Context.fill rect 0 0 width and height. Save that and see if our game loop is working. All right, so everything is nice and green. When I resize, it fills up the entire window. And to just show you what's happening here, I'm going to subtract 10. This way, the width and height of our canvas is just 10 pixels shy of filling up the entire browser window. So now you can see that it's going to be consistently 10 pixels shy of filling up the entire browser window there. All right. So now we are in business. So now I'm going to go ahead and load up the sprite sheet. So this is the sprite sheet that I'm going to be using for the example. I've got some basic ground tiles, I've got a wall tile, and I've got the player sprite. So before I even execute my loop, I'm going to have to load this image because I'm not going to be able to draw until my sprite set or sprite sheet is loaded. So I'm going to go ahead and say, actually let's call it tile sheet equals new image. I'm going to create an image to load my sprite sheet into. I'm going to say tile sheet dot add event listener load, And I'm going to make an arrow function to handle the event. And once this is loaded, once it detects that the image is loaded, I'm just going to call loop, and that's going to start my game loop. So that's literally all I'm doing. Once the image is loaded, it's going to start the game loop, and things are going to kick off. I also have to say tile sheet dot source equals tile scroll.png, because that is the URL of my sprite set right here. Alright, so now I should have access to the sprites. What I'm going to do is I'm going to define a sprite size. I'm going to come up here to all of my tile information variables. I'm going to say var sprite size equals 16, because each one of these tiles is 16 by 16 pixels in dimension. And let's go ahead and make a player class too. So I'm going to come in here, const player equals function. It's going to take x and y as parameters. This.x equals x, this.y equals y, and that is my player class. Close it with a semicolon, because I'm declaring it kind of like a variable here instead of a function like this. So now I have a player class. I'm going to go ahead and define my player. Player equals new player, and I'm going to set his position at 100, 100. So x and y are going to be 100. All right, now let's go ahead and draw the player. So I'm going to say context.draw image sprite sheet. Oh, actually, it's not sprite sheet, it's tile sheet. And I'm going to go ahead and say the source x position for the sprite is going to be 64 pixels, because these are 16, so this is going to be 0, this is going to be 16, this is going to be roughly 32, then 48, and then 64. So this player sprite starts at x of 64 in the context of sprite sheet. So I'm going to say source x of 64, source y of 0, because it's at the top of the image, and of course sprite size and sprite size, because that's going to be 16. Also, I'm going to need to hand in the player.x and the player.y, and I'm going to scale him up. I'm going to scale all these graphics up actually, but first let's go ahead and see what the base looks like. So 16 and 16. And let's get something on the screen just so we can have something on there. All right, so that's him on there. If you can see it, he's really tiny. So that's why we want to scale him up. So let's go ahead and create a variable called scaled size. There we go. I'm going to call that 32. Or I'm going to put 32 in there. So the scaled size is going to be the size that I'm going to scale all my tiles up to. So scaled size and scaled size. Let's go ahead and do this again. Now he is scaled up a little bit, but he's pretty blurry. So what I need to do is I need to set context dot, what is it? Image smoothing enabled equals false, and this is going to sharpen up our sprite. All right, now he's nice and sharp, looking sharp there. The next thing I want to do is I want to go ahead and draw my map. So I'm going to go ahead and make a basic loop here, but it's going to be an X and Y loop. So I'm going to loop over X and Y in the map respectively. So the columns and rows I'm going to loop through. I'm not just going to loop through every tile in the map. And the reason is because for scrolling, you kind of have to do it this way. So let's say for let X equal 0, X is less than columns, X plus plus. For let Y equals 0, Y is less than rows, Y plus plus. And in here, we're just going to say the same stuff down here. We're going to do context.draw image. Don't know why it went all the way over there like that. We're going to go ahead and get the tile value out of the map. So we're going to say let value equal map y times columns plus x. That's the formula to get our two-dimensional map converted into the one-dimensional map array coordinates to get the value out. So then I'm going to go ahead here. I'm going to say we're going to draw the tile from the tile sheet. We're going to say value times sprite size, because all of our sprites are 16 by 16 pixels. We're going to go ahead and say 0. That's the same. Sprite size and sprite size are going to be the same as well. Then this is what's going to change right here, just the x and the y values. So I'm going to replace those with tile x and tile y, and I'm about to create those right here. Tile x, thinking ahead of myself, I didn't even put the let in there. Let tile x equals something, let tile y equals something else. So tile x is going to be literally x multiplied by tile size. Y is going to be equal to y multiplied by tile size. And let's see what we get. Probably an error because I wrote that kind of quick. Yep, we're getting some errors. Let's see what it is. Uncaught reference error, tile size is not defined. That's because I'm using not tile size but scaled size. Scaled size, let's see what happens now. All right, now we have our map. The only thing is, it doesn't do anything yet. We're not moving and it's not scrolling. And actually, the map is going off the screen. If I make the map, or if I make the browser window a lot bigger, the map is going to be drawn, but the map is just being drawn off screen and we can't see anything of it. So we actually have to scroll to see all that extra stuff in the map when we move the player. So before we do that, let me go ahead and get rid of this green here because we don't need to draw the green anymore. So as you can see, I'm drawing a little bit of green on the background there. Don't need that, so I'm going to save, going to refresh, and now there's no more green, it's just black. So let's see, what do I want to do next? Next, I'm going to move the player. So next we're going to move the player, and we're going to have context.canvas.add event listener, click event, and let's say pointer x equals pointer.x equals event.page x. Pointer.y equals event.page y. Okay, cool. All right, so we just created a value called pointer, and we're going to set it to event.pageX and page y when we click. So when we click the canvas, the page x and y values are going to be the x and y values of the map on top of the canvas, actually on top of the window. I don't think it's actually relative to the top left corner of the canvas, but it would be nice if it was, but we'll figure it out and make it fit. I'm also going to come up here and I'm going to go ahead and define var pointer equals an object literal. I'm going to put an x value in there, 0, and a y value in there, 0. And I'm also going to go ahead and come up here and make the player move towards the mouse position. So player.prototype equals an object literal. And we're going to go ahead and have a move to function in here. So move to, so player.move to is going to be a function. It's going to have an x and a y position inputted to it or passed into it as parameters. And I'm just going to say this.x plus, well, actually, let's just say this.x equals x for now, and this.y equals y. And we'll get to the smooth movement later on. Let's just see if it works for now. Oh wait, I haven't actually implemented it yet. So let's go down here into the game loop and go ahead and before we draw the player, we're going to say player.move to pointer.x pointer.y. Save. I'm going to refresh. And now I have my player character moving to the exact position of my mouse, and that is exactly where I want it to be. Cool. And I'm also going to come in here and I'm going to say, let's move him to the center. X minus, should I do scaled width? Let's do half of scaled size times 0.5. So now what I'm doing is instead of having him move by his top left corner, by the top left corner of the actual sprite image, what's going to happen is when I refresh, he's going to be centered on the mouse instead of being moved by his top left corner. So I'm just subtracting half of scaled size from the X and Y position, and that's the reason he's moving to the center now instead of by his top left corner. The next thing I'm going to have to do to get this to scroll is I'm going to have to define some kind of viewport region. So I'm going to just make a class. I'm going to call it Viewport. Viewport equals function. It's going to take X, Y, width, and height. So X equals X, this dot Y equals Y, this dot width equals width, this dot height equals height, and let's actually come down here and define a prototype. Viewport.prototype equals just an object literal. So now I have a region, a rectangular region that I want to view my tile map through. So let's come down here and actually make a new viewport. And I'm going to say the viewport is going to start out at X of 0, Y of 0, and it's going to have a width and a height of, let's say, for now, let's just say 100. And that's it. Cool. So how do we actually make this work? So inside of our game loop, what we're going to have to do is we're going to find what tiles are actually underneath the viewport's X and Y width and height dimensions. So what tiles in the map are actually going to be underneath the rectangle of our viewport, or you could think of it as a camera too, I guess. So how we do that is we start out by getting the minimum column value for our tiles, our visible tiles, and the minimum row value for our tiles, as well as the maximum values. So I'm just going to say var x min equals math.floor viewport.x divided by scaled size. Same thing for ymin, math.floor viewport.y divided by scaled size, and maximum is going to be xmax equals math.ceil, because remember we're getting the maximum now, so we don't want to round down, we want to round up to get the maximum value there. So math.ceil, and we're going to do viewport.x plus viewport.width, because we're getting the right side of the viewport rectangle, divided by scaled size. Same basic concept for ymax. All right, so now we're going to go ahead and down here, instead of setting X and Y to 0 and looping all the way up through columns to draw this entire map, what we're going to do is we're only going to draw the portion under the viewport. So we're going to go ahead and set this to X min, and we're going to set this equal to X max. We're going to set this equal to Y min. We're going to check to see when it's greater than Y max. All right, so let's see what we get. All right, so our map now is very, very small because we set this kind of small here. Let's make our viewport a little bit bigger. Let's say 300 and 300. Cool. Now let's try something different and forget about the location of the player. Let's go ahead and try scrolling to 100, 100, and have 300 by 300. That's going to scroll us down all the way to here. But if you noticed, the map is now moving to that area. We're not really scrolling the map so much as we are moving the viewport over the map and just drawing the viewport instead of the entire map. So if I were to do this and say 200 and 200, the viewport would just move further down that way and draw what's underneath it. So how do we combat this? How do we remedy this? Well, we're going to have an offset value. So the offset is going to be the viewport's X and Y position. So what we're going to do is we're going to actually subtract the viewport's X and Y position from where we draw the tiles to, and also where we draw the sprite to. So let's go ahead right here where we're drawing tile X and tile Y, and we're going to subtract minus viewport.x minus viewport.y. See what happens. All right, so now we're scrolling, but the viewport is actually going to be in the correct location. It's not going to be all the way down here. It's actually going to be up the top left. So now let's just do a little test and see what happens here. I'm just going to come in and I'm going to say inside of the loop, I'm going to just say viewport.x plus plus. Cool. All right, so the map is scrolling. How about that? Pretty cool, right? So as it moves, it's just going to draw the new tile as it comes into its viewport region there. And actually, to give you a better idea of what's happening here, I'm going to go ahead and I'm going to draw a rectangle over top. I'm not sure if that's actually working correctly or not. Let's see. But I'm going to go ahead and draw a rectangle to represent the viewport. So let's go ahead and draw that rectangle. Context.stroke style equals white. Context.rect, and let's say viewport.x, viewport.y, oh wait, I don't have width and height, I just have W and H. Context.stroke. Okay. Actually, what I'm going to do here, because this is the actual location of the viewport, but actually for right now, we're just going to do 0. So let's go ahead and put 0 in there. This way you guys can just see what's going on here. Okay. Why is it no longer scrolling? Because I got rid of that line. All right. So as you can see, this is supposedly the visible region. I'm still drawing everything. Normally you would want to clip off all this extra stuff that falls outside of this white rectangle. But since I'm not clipping, and I'm not going to in this example program, we're drawing everything outside anyway. But ideally in the game, you would only ever see what is on the inside of that white rectangle. So if I were able to drag this over here and make my screen a little bit smaller, you would only be able to see the visible scrolling region. So let's go ahead and try this with Y instead and just do Y++. Okay, so now I'm scrolling down and it looks great. You can't tell that anything's being drawn out there, but let's go ahead and expand this a little bit so you can see. Now it might not make sense to you, but what's happening is I'm not clipping, so normally you wouldn't actually see the tile drawn on the outside of the white rectangle. So anyway, that's just going to be my viewport region, this white rectangle here. So let's go ahead and get rid of this because we don't actually need it. We're not going to scroll that way. We're going to go ahead and we're going to scroll based on the player's location. So next up, what I want to do is I want to center this in the middle of the screen because it looks kind of dumb being up in the top left corner like that. So I'm going to come over here and I'm going to go ahead and say minus viewport X, but also, let's see here, plus width times 0.5 plus height times 0.5. I'm going to center this inside of the browser window. That's why I'm getting width and height. That's the width and height of the inner dimensions of the browser window there. So when I save, this is going to look wrong. It's going to be all the way down here, but what I'm not doing yet is subtracting viewport.width times 0.5, and a lot of this is just simple math, but it gets complicated because you're working with a lot of different variables. But right now I have everything centered. So over here, what I'm going to do to draw the frame, the viewport frame in the right location, I'm just going to fiddle around with it a little bit. Let's see what we can do here. 0, 0, I'm going to do width times 0.5 minus viewport.width times 0.5. Let's see if that's the correct location there. Yep, that's the correct location. Over here, we're going to do height times 0.5 minus viewport.height times 0.5. That's going to go ahead and center our viewport indicator. It's not actually going to do anything to the viewport. It's just going to draw the location of our viewport physically. Okay, cool. So now if I would go ahead and type, let's see here, let's type viewport.x++, we can go ahead and get a much better idea of what's going on here. So as we're moving the viewport to the right over top of the map, what's happening is tiles are being moved into view and they're appearing on the right side. And on the left side, tiles are moving out of the visible viewport region, so everything inside of the white square, and they're being removed. Pretty simple. Now, you can't really tell just by looking, maybe you can, but there are lines between my tiles. So the reason for that is because I'm not actually rounding my tile locations down. So what I'm going to do is I'm going to come in here, I'm going to say math.floor. Math.floor. Going to encapsulate that with a close parentheses. And now we no longer have those lines that split everything up and make it look not so good. Okay, so now we have the scrolling down. All we need to do is scroll to the player's location instead of scrolling to just, viewport.x+1. Okay, so here's my player my player location, so my player.x and .y. Now what I want to do is I want to go ahead and create a scroll to function inside of my viewport's prototype. Scroll to is a function. It takes an x parameter and a y parameter. And inside of it, we're going to say this.x equals x minus this.width times 0.5. And that's going to scroll us to x and y, whatever x and y we hand in there. This.y equals y minus this.width times 0.5. So there's our scroll to function. Let's go ahead and just scroll to the player's position. Oh, I'm going to put that before these. So scroll to player.x, player.y. Down here, we're going to take this. We're going to move the player right before we scroll to his position. All right, let's see what that looks like. It looks kind of messed up. So the reason it's messed up is because we are not offsetting the mouse pointer by the scroll location. So what I'm going to do is I'm going to go ahead and I'm going to move the pointer's location to the offset position that we're scrolling by. So let's go ahead and modify this right here. So we're going to do event.pageX, only it's going to be plus viewport.x minus width times 0.5, so center in the canvas, plus viewport.width times 0.5. Same thing for page Y, plus viewport.y minus height times 0.5 to center in the screen, plus viewport.height times 0.5, and hopefully I don't have any glitches there. Probably do. Nope, I don't. Okay, so now the only problem is we're not offsetting the player's location. So let's go ahead and come up to the player. This is the player location here. This is where we're going to go ahead and do the offset for the player's X and Y position. So we're going to go ahead and use math.floor again, or actually math.round, math.round. And we're going to say player.x minus viewport.x plus, we're going to center them in the screen, width times 0.5 minus viewport.width times 0.5. Let's see what that looks like on the X position. Not quite. Let's go ahead and do the same thing for Y just to be sure. Math.round player.y plus height. Oh, I'm forgetting to subtract viewport.x. Actually, no, I'm not. Viewport.y minus viewport.y plus height times 0.5 minus viewport.height times 0.5. Save. Alright, so now the player is actually centered inside of the window here. And I can move around, but he's not moving to my mouse location. Actually, he is. See where I'm clicking? I'm going to click right on the edge of this tile here. And he moved right to the edge of that tile. If I click right on the top edge of this tile, he's going to move right to the top edge of that tile. But it's not very smooth. It's extremely rigid. So what I want to do is I want to update his move to function to actually be smooth. So I'm going to go ahead and update that. Let's go up here. Player.move2. Instead of just setting it to x minus scaled size times 0.5, what I'm going to do is I'm going to make this this.x plus equals x minus this.x minus scaled size times 0.5, and I'm going to ease that by saying multiplied by 0.05. So you're going to see what this is going to do in just a minute here when I run the code. Y minus this.y minus scaled size times 0.5 to center them on the mouse. Remember that. All right, there we go. And now he moves nice and smoothly. So when I come to some place and click, for instance, here, he's going to move there. And I'm not exactly sure what's going on up here because this is jagged and that is definitely not supposed to be that way. I think what's going on is everything is rendering properly when I'm inside of the boundaries of the map. But when I get to the outside of the boundaries of the map, things get kind of messed up. Like right now, I'm just scrolling all the way over and that's definitely not supposed to happen. So what I need to do is I need to add some parameters to prevent him from going off the map. So let's come down to our game loop. And here we're going to go ahead and put some conditions on our xmin, ymin, xmax, and ymax variables. So if xmin is less than 0, xmin equals 0. So what this is going to do is it's going to solve this problem right here. This is pretty close to the top left corner of our map. So if I come in here and I scroll up, you can kind of see that I have this little room. 3s are the wall tiles. I have this little room and it's corresponding to this right here. This is the top left corner of the map. But when I try to go left, it starts drawing the far right corner of the map, offset down by 1 tile. That's because I'm literally starting to draw over here, this side of the numeric array over here on the left side of my map because I don't have any parameters to stop myself from drawing that. So what I just did with that if statement was I said if the minimum x tile is less than 0, make it 0 because we don't want to draw that other side of the map. So now I can't draw that other side of the map. So when I get to the edge, it doesn't try to draw this stuff over here. It just doesn't do anything. It doesn't draw it. And that's what you want. So now I'm going to go ahead and do the rest, and we should be able to scroll around this map. So let's see, where am I? Getting lost in my own code here. If ymin is less than 0. Ymin equals 0. If xmax is greater than columns, and this is going to do the same thing for the right side of the map. So, for example, if I try to go all the way to the right side of the map, right here, this is the end of the map. This is the very edge of the map. And if you'll notice, I have this formation of grass here because I'm going to set this right here, and you're going to see that that's the edge of the map right there. So if xmax is greater than columns, so if it's greater than the number of columns in the map, xmax is going to be set to, oh, wait a minute. Xmax is just going to be set to columns. I'm going to save that. Remember this formation right here being on the end of the map. All right, and there's the end of my map. And there's that formation again. So basically what I'm doing is I'm just saying if I'm trying to draw tiles that are off the actual edge of my map, just don't draw them anymore. Set columns or set xmax equal to the maximum column in the map. Or if I'm going off the left side, set xmin, or the minimum column I'm going to draw, equal to 0, because there's nothing lower than 0, or column 0 in my map. There's nothing lower than, or higher rather, than row 0 in my map. And likewise for the lowest row, if ymax is greater than rows, which is also 24, ymax is just going to be set to rows, because there's nothing below the lowest row in my map. Okay, so now I have a fully scrolling tile map. And the player character does go off the boundaries of the map, but I mean, whatever. It works pretty well. So anyway, this is all the code to make a scrolling map right here. To do some other cool stuff, I might just add like a little cool bonus effect here to interact with the map. So what I'm going to do is I'm going to say, let's come down here and do something cool. What I'm going to do is I'm going to make it so when the player walks over a grass tile like this, it's going to get stamped down into one of these types of grass tiles. So I'm just going to say, I'm going to get the player's index in the map. So player index equals math.floor player.y plus scaled size, I believe is the tile size. Half of the scaled size, so that's going to get the player's center on the y-axis, divided by, let's see, scaled size. All right, so this is basically going to get our player's index in the map based on the center of the player. I'm going to say if map, if the index in the map at the player index is equal to 2, which is the value for our grass tile. Up here, the grass tile is going to be at index, this is index 0, this is index 1, this is index 2. So this grass tile is going to be a value of 2. If he's at a value of 2, map, the value at the player's index in the map is going to be set to 1. Let's go ahead and see if that code worked. All right, so now we could actually trample our grass tiles. So I'm not going to go over stuff like scrolling off the map and stopping the edges of the map from scrolling anymore once you get to a certain point in the map. But this is basically how you draw the map. The thing that you need to really focus on is this right here. Getting the minimum column and the maximum column, the minimum row and the maximum row, and looping through those values to draw your tiles, as well as the formulas in here to get the offset position of the viewport, to adjust the tile positions as well as the player sprite positions. It looks complicated, but it's really not that complicated. And anyway, that is how to draw a scrolling tile map.